and then I'll see if anybody else has other questions. So if you go to textbook, you online, remember the homework is in practice and homework, right? So if you hit practice, that's number 1 through 5 there. If you go to homework, it starts at number 42, right? Oh, update, sure, go ahead. Do it. Really? Okay. So this is the section I'm talking about. I think in this section you had to do 45, 48, 49. This little section here, I don't know if you guys can see that. Let me zoom in a bit. So the homework assignment is 1 through 5, and then it goes to 45, 48, 49. So this section here is a little bit freaky. The instructions, the correct answer to any of these is not A or B or no. For each problem, you have to identify all of those things, right? So read with me. So every problem, you have to answer A, B, C, D, E, F. Okay. So let's do an example problem. So last time we talked about some definitions. After we did some group activities, we did population, sample, parameter, statistic, variable, data, right? You guys all with me? Population is who we want to say something about. Sample is the subgroup we work with. Variable is the question we ask. Data is the answers we get. Statistic is what we do with the data, average or percentage. Parameter is a description of the whole population, right? Does that sound vaguely familiar? Okay, all right. So let's try one. Number 42. So a fitness center is interested in the mean amount of time a client exercises in the center each week. Have I told you guys yet? The official name for what we call average is mean. The word average means more than what we think it means, right? So the real name for what we consider average is mean. Okay, so looking at that, that's all they give me for this problem. Can somebody tell me what the population would be? Now be more specific. Whose clients?
The fitness center's clients.
Good. And which ones? Which clients?
All.
All of them. Good. So all of the fitness center clients. Are you guys with me? Mm-hmm. It's really good to write this down because this will be a sample because you got to do 45, 48, 49. So the population would be all of the fitness center's clients. Cool. Notice they say give examples where appropriate, because when they say the sample, does it say anything about a sample in what they told us? No, so we're going to give an example. Can somebody give me an example sample? Yes?
A randomized number of the clients.
I love it. So you could just say some number of their clients, you could just say a subgroup of their clients, or you could say 87 randomly selected clients. Is everybody sort of with me? So when they ask you for the sample, that's why they say give examples where appropriate, you have to come up with some example. All right, how are we doing so far? Okay. So let's say population is all the fitness center clients. Let's say the sample is 87 randomly selected clients, right? Parameter. What does the parameter describe? Yeah. Parameter describes the population, right? When it turns out, you know. And statistic describes a sample. You gotta love that shit. Doesn't happen often enough in math, right? What was our population again? It was all fit clients of the fitness center, right? So the parameter would be what they are trying to say describing the population. So what are they trying to figure out? The mean amount of time. So it would be the mean amount of time that all clients work out in the center. So when you answer a parameter question, it better describe whatever the population is, right? And if you wrote down a population, whatever you wrote down better show up in your answer for the parameter. Does that make sense? The parameter describes the population. So whatever the hell you said the population is, better show up in your answer for the parameter. So again, the parameter in this case would be the mean amount of time that all clients of the center work out in the center. Right? Statistic is going to be almost the exact same thing. But what does a statistic describe? I'm sorry?
The sample.
The sample, kick ass. So this would be the mean amount of time that the 87 randomly selected clients worked out in the center in a week. I really want you guys with me. You guys with me? Parameter will always sound almost exactly like the statistic. They're going to sound a lot alike because they both say the same damn thing. They just say it about two different groups. One is talking about everybody. The other one's talking about a subgroup. All right. Variable. What's the variable related to? In general, the variable's related to the question you would ask. So if you had a bunch of these, if you had the 87 clients, what would you ask each one of them?
How much they work out.
How much they work out. So the variable would be the amount of time a client works out each week. I think it was each week here. Yeah. Do you guys see how to do that? So when I say what's a variable, you just think, what the hell would I ask these people, or what would I look for, right? That's pretty much the variable.
Can you repeat the variable again?
Yes. So the question would have been, how long do you work out, right? That's what we'd ask the people to be able to figure out the average, right? So the variable would be the amount of time a client works out. That's related to the question.
You don't have to specify like the amount of time each client in the sample group works out.
No, because it would be sort of like you're asking one person at a time.
Okay.
So the variable would be that question you're asking each person. The data, if you're using words to describe the data, you're almost definitely wrong, because the data are the answers. So that's another place you have to give examples. What could somebody say? What could an answer be to our question? 30 minutes, right? Really good weekly workout.
Or like whatever how much the clients work out per week, but in numeric value.
Totally. So give me an example.
Well, if you can write that down, would that be acceptable?
No,
Oh, okay.
definitely not. 30 minutes, comma, 7 hours, comma,
What if-
0 hours, because I just have the card so I can pretend like I work out, comma, 24 hours, comma, I live in the center, so, right? There's people that, no matter what time I go to the gym, they're there, and they freak me out. Like, do you ever leave? Do you ever get off that machine? Oh, sorry. Maybe some make it relevant. Yes?
Yesterday you said that parameter was a number.
It's a numerical description of the population, yes.
And not a legit like number.
So in this case, we're describing what the parameter would be, right? So you could, if you wanted to, since they say give examples, you could say the mean amount of time that all the clients worked out was 7 hours. You can kind of make something up because it does say give examples. I would argue it's not really needed for that. You can just describe what the parameter would be, since we don't really have data to work with, right? They would have had to ask the data question first, and then we could have actually calculated an average. Does it make sense? So there's some wiggle room with some of this stuff, right? And please understand, I am never, and neither will the book, I or the book will never say define population. Never. It's always use the word in the right way, right? Okay. Yeah. So if you copy that down, it's a little template for the ones you actually have to do for homework.
So the data can just be
Data can be numbers. I mean, if the question, let's say that I was interested in the percentage of people that are going to vote for Biden, right? What would one question I could be that would ask somebody? Who are you going to vote for, right? But then, so then the data would be what? Biden, Trump, DeSantis, whoever else crazy person would vote. Yeah, okay. Y'all with me? That's as close as I want to get to discussing politics. All right. This in the past, okay. All right.
So it's just be more quantitative than qualitative?
It would be qualitative, yeah. So remember, the two types of data are qualitative, quantitative. Either one can show up anytime. If it's qualitative data, could I do an average? Can you do the average person people are going to vote for? How do you add Trump plus Biden? What does that equal? All right. I don't want to get any weird Dragon Ball Fusion things happening, but that would look really strange. Sorry. See an orange old man. Oh. So, if it's qualitative, the reason I want you guys to know qualitative, quantitative exists is because there's certain things I can't do to qualitative data, like take an average. I could do a percentage, the percentage of people that are going to vote for somebody. Yeah. Everybody with me? Everybody understand this section of homework? You got 3 problems from this section, and you have to do A through F. The sample and the data are the 2 main places you just have to come up with examples. It doesn't say that in the problem, right? Anything else from homework? If anybody's started to try it yet? Any other questions from the homework? Yes?
What about the data tables for question 16 on section 1.2? Do you want us to actually like copy down the table?
Oh, yeah,
Okay, cool.
because that's I've had people just print it out and then fill it in, so you can do that if you want to, but you basically have to create this table, yeah.
Oh, but if you like did it yourself, it would be accepted.
Yeah. Totally. So we're gonna get into this today. We haven't talked about this stuff yet. We've barely done anything. Which is fine, because the first day was full of a lot of other stuff, right? Anything else? Questions, homework, technical stuff?
So in conclusion, for like the question we were doing, so we basically give any example we want.
For the sample, you could say something like a subgroup of whatever, right? Because the sample is a subgroup of the population. Or you could say specifically 111, right? So if the population was all the giraffes in Africa, your sample could be a subgroup of giraffes, or it could be 89 randomly selected giraffes. Does that make sense? Yeah. So you got a little bit of room as to how to word your example. Yeah. All right. Everybody okay? Okay. Anything else? Okay. So we're gonna continue where we left off. Oh, good. I got a little worksheet you guys are gonna work on together here in a bit. Okay. Yep, that's for this thing. Shoot. Sorry, man. You have to take up some room. All right. Let's see. Let me put this guy. So, I've already warned you that we're doing a bunch of definitions. I know they're very exciting, but we're not going to be able to do them forever. We're going to get done with the definitions, at least these definitions today. So last time we did the ones we just talked about. Oh, that's right. We haven't officially, did I talk about qualitative, quantitative? All right. So that's why maybe some of you guys are like, what the hell are you doing? Hello. So let's do this. Yeah, let's go ahead and do that. So qualitative.
You're not in frame on the phone.
Thank you. Quantitative. I'll get there in a second. I did move it over, didn't I? Yep. Boop. All right. Like quantitative. Let's look at that first. What's the root word of quantitative?
Quantity.
Quantity. Okay, so it makes sense that quantitative data would be truly numerical data, like measurements, an amount of stuff, right? So quantitative data is truly numerical. What do I mean by truly numerical? Does anybody play any sports here? Do you guys play a sport where we have a jersey number or something? What's your jersey number? 22, okay. Is your jersey number truly numerical? Like, tell me another jersey number of one of your teammates.
7.
What does 22 minus 7 mean something physically? Do you understand what I'm saying?
Not really.
No. One semester, 22 minus 7 was 15, which was another person's jersey number, which is hilarious. Because I said, what's 22 minus 7? They went, Michelle! Oh, shit, all right. But Jersey numbers aren't truly numerical. Jersey numbers are another name for you, correct? You can say, there goes number 22 down the sideline or whatever, right? I'm not sure what fits in your, what sport do you play? Soccer. Okay, so that would work for this. Okay. You guys all with me a little bit? So quantitative data is truly numerical, meaning you can add it, you can subtract it, you can divide it, you can do all the numerical stuff to it. So for example, zip codes. Are those quantitative data? If you subtract 2 zip codes, does the answer mean something physical? No, it doesn't mean shit, right? If you divide 2 zip codes, it really doesn't mean anything, right? You guys all with me? Okay. So qualitative data is also called categorical. It's just name data. Like everything I just said, the jersey number, the zip code, those are types of qualitative. Hair color, names of cars, whatever. Things that are just names that aren't numbers. Pretty simple, right? Gotta love that shit. So now let's break it down even further. So we have certain levels of measurement. So we have variables that have different levels of measurement. For example, the most basic level is exactly what we were just talking about, would be name data. And that's called nominal data. Has anyone ever read any Stephen King books? You like Stephen King? All right, I like it, very honest. She's like, I'd give him about 2.5 stars. If you like Stephen King books, did you know that when he first started writing, he didn't go up by the name Stephen King?
Yeah, he wrote Running Man under someone else's
Say again?
name. He wrote Running Man under
True.
some other dude's name, like Richard.
So if you really like Stephen King, he went by what's called a plume de nom, a pen name. So nom is name. He went by the name, do you know?
No, but I said it could be called.
So his name was Richard Bachman. That's what he called himself. So if you really like Stephen King, look up Richard Bachman. Some good shit in there. All right. You don't have to know Stephen King, okay? You with me? It's just a little example. Plume de nom, pen name. So nominal is just name data. All it is names. So of course that means that this is a type of qualitative data, right? Name data. So again, examples would be hair color, make of car, jersey number, blah, blah, blah. The second level, there's 4 levels. The second level is still name data, but it's names that have to be in order. So what the shit does that mean? Has anybody ever filled out an evaluation for an instructor? Where you bubble in the circles, anybody? You guys? So basically what it is they have a statement like, my teacher cares about me. And then they have these strongly disagree, neutral, agree, strongly agree, right? If you ever got one of those and it went agree, neutral, strongly disagree, wouldn't you go, wait a minute, what? Are you trying to mess me up? Right? If that was not in the right order, it would make less sense, correct?
No.
So the next level of data is name data that must be in a certain order to make sense. So this is called ordinal data. Makes sense. Ordinal, order, right? There's an inherent order to the data. So for example, if I start listing off cars in the parking lot and I say Hyundai, BMW, Chevy, are you going to be, I know, Hyundai next to I just like to say Hyundai, so I'm sorry. It's like whipped cream. All right. Hyundai, BMW. Is everybody going to be concerned that I didn't put BMW first? Could I put cars in alphabetical order? Could I?
Yeah.
Do I have to?
No.
Okay, so they're not ordinal data. They're just name data. Anything that must be put in order, any ranking that you do, right? If you want to go to a restaurant, do you ever see something that says rate our service? Excellent, good, fair, poor. So if they put that out of order, you're like, wait a minute. Are you guys trying to trick me, right? I mean, they should be in this order because I'm going to rank you. Maybe. Okay. Yes.
What does that say?
I wish I knew. Sorry. Even on a good day, I can't write. And then this is the last class in a very long day, so you're going to have a great time with me. I'm sorry. I did have a teacher once that he would write stuff, and then somebody would be like, "Hey, what'd you write up there?" And you go, "Oh, does somebody remember what I wrote?" And I'm like, if I ever do that, I'm retiring. I'm out. I can't. So at least I can still read my own writing. So is that better? I'm sorry. All right. These next two are both quantitative. So these two are qualitative. So if you know that the data you're looking at is qualitative, it's just name data, then you can figure out between these two which one is it. If you know what you're talking about is actually really numbers, then you can figure out between these two which one is it. So I have to write both of these down to make sense. There's one called interval, and there's one called ratio. If I said there's a certain interval of time, does that make any sense to anybody? What, give me an example of an interval of time. Sure.
Maybe like every 3
Maybe? Yes?
Midnight to 6 a.m.
There, that's an interval of time, right? How long would that interval be? Midnight to 6 a.m.
6 hours.
6 hours. How do you figure out, well, that's not the greatest example, because, clock math isn't really, because 6 minus 12 is not, right? But if I said everybody who's from 4 years old to 9 years old can sign up for this thing, right? How long is that interval? 5 years. So interval data is data that subtraction makes sense. You guys kind of with me? So for example, subtraction makes sense. Can you subtract 2 zip codes?
No.
Try again. Can you?
Yeah.
Does the answer make sense?
No.
Doesn't mean shit, right? Can you subtract 2 jersey numbers? Yes. Does the answer make sense? No. You with me? Those are not interval data. Can you subtract 2 years of birth? Anybody willing to tell me what year they were born?
2000.
One person. Somebody say yes. Okay. What year were you born?
2005.
2005. So if you take 2005 minus 1972, the answer, I love that reaction, that's awesome, thank you. You get an answer, does it make physical sense? Try again.
I would guess, but like.
That's how many more years on the earth I've been, yes? Does that, so there's a physical interpretation of the answer, therefore that would be interval data. You guys with me? I like it. So when you get a question like this and it says, what level of data is this? Come up with 2 examples and see if subtraction makes sense, right? So interval data, subtraction makes sense. So like year of birth, oven temperatures. All right, now before we get too far, because it's a little bit weird, the overlap between these two. Ratio, when I say ratio, what does that mean mathematically? Ratio. What operation does ratio? Division, right? Ratio is like fractions, and that's division. So ratio data is data that you can divide. Can you divide, not can you, but does the answer make sense? If I take 2005 divided by 1972, could I do that? Yes. Does the answer mean anything? No. Doesn't mean shit. You with me? So division has to make sense. Anybody in here 25 years old? Oh, interesting. You were 25?
24. Close enough.
I like it. For very large values of 24, you were 25.
What does that say over more?
Oh yeah,
Oven
oven temperatures, yeah. You really, the way to work this is to listen to what I say. So oven temperatures, yeah. I'm sorry. All right, I'm 50. If somebody's 25, 50 divided by 25 is 2. Does that make physical sense? I'm twice as old, yes. As a physical interpretation of the answer. You guys with me? If I divide 2 years, the answer doesn't have a physical interpretation. Now the funny thing is, there's a second thing that this has to do. 0 must mean what it's supposed to be. What should 0 mean?
Nothing.
It should mean nothing. It should mean the absence of thing, right? So for example, what temperature scales do you guys know? What do we use here in the States? Fahrenheit. What else is there the rest of the world? Celsius. Anybody know a third one? Ooh, Kelvin. If you don't know Kelvin, it's okay. But Kelvin is the one, if it's 0 Kelvin, everybody's dead. 0 Kelvin means no energy. So I was doing research where I was cooling atoms to just above 0 degrees, and then I was poking it. It was really neat, right? Anyway, you don't have to know that shit. I just like to say that because it was really neat. The scales we use, Fahrenheit, does 0 mean the absence of heat? Therefore, Fahrenheit degrees is not ratio. 0 does not mean the absence of what I'm measuring. If I said the number of woodpeckers in a tree, is that ratio? Would 0 mean what it's supposed to mean?
Yeah.
It would mean no woodpeckers in the tree. Therefore, that's ratio. If I saw 10 woodpeckers, and then I saw 5 woodpeckers, then 10 divided by 5 is 2, twice as many, blah, blah, blah. You guys with me? So the way, when you get a problem like this, it's going to tell you something like social security number. So then you're like, okay, is it qualitative or quantitative? Well, social security number is, well, which one is social security number? Qualitative. So it's one of these two. Now here's where you could argue. Do you guys know, very quickly, my social security number, the first 3 numbers, don't get too excited, 258. Anybody else have a 258? 258 means I was born in Georgia. Oh.
So that's why mine starts with 619.
Maybe. I don't know.
You're in California.
Yeah. So does anybody else have a 619 beginning of your social? Okay. It might not be perfect because, you know, I was born like a long ass time ago. So since then they might have had to include more numbers. But so you could sort of argue for ordinal, but I would actually say it's more nominal. Are you guys with me? So when you get a problem and they tell you something like, what's a good example? I don't know, weights of fish, right? Is that, so if I have weights of fish, is that truly numerical or is that not numerical? Give me an example of a weight of a fish in kilograms, or pounds, let's say in pounds, because we're in the States, I'm sorry. 2.2 pounds. 2.2, right? Okay. Is that truly numerical? Could I subtract 2 weights? And the answer makes sense, for example. Yes. But you have to answer with the highest level. Is it ratio? Does 0 mean what it's supposed to mean? If a fish weighed 0 pounds, what does that mean? Absence of fish, right? I went fishing and, I caught this 0 pound. Boy, it gave me a big old fight. You didn't catch any fish. Well, yeah, you can put it like that, right? It's a very interesting way to say, I didn't catch anything, right? You guys kind of with it? So that you're going to get problems in the homework. It says, okay, here's the situation. What level is it? So you got to think, is it number or not? Because then you can break it down to 2, and then you can figure out between these two or between those two which one it is. Okay, maybe. Okay. More definitions. Let's see if it comes back. Is this going to come back? Go away. All right. We talked a little bit about this last time. Remember what I said stratified at one point? We're talking about different ways to sample things. So let's focus on sampling methods. Just to remind you guys, I'm not going to be talking the whole entire class. I do have a worksheet for you to work on. So I'm going to shut that up in a little bit. The gold standard sampling method that any other sampling method wants to be is what? What's the best ultimate sampling that we want to have happen?
Random?
Random.
I was gonna say simple random.
Gotcha. Simple random, even better. Does anyone remember what random sampling required? What's got to be true?
Being selected.
Say again?
The equal chance of being selected.
Yes, beautiful. Everything in the population must have an equal chance to get in the sample. Or I can kind of simplify it. Everything in the population has to have a chance to get in the sample. Equal chance, it actually is true. You guys kind of with me. We talked about this last time. If there's anything in the population that has no chance to get in the sample, that is obviously bad. That group then can never be included, so your data will almost always be biased. Are you with me? I like it. So random sampling, every element of the, oh, this is neat, population has a chance to be in the sample. Okay, this is weird. I think it helps me write a little bit. Still terrible. All right. Yes,
What does it say after half?
I don't know. This here
Yeah.
has a chance.
Oh.
A chance to be in the sample. Yeah, the word be really just didn't come out there. So now, any other method? So this would be like putting names in a hat. There's no method to it. It's just put names in a hat. That's random, right? You everybody with me? Okay. Now I'm going to have these other methods, but they all need to try to be random. But they have more of a system in place. In fact, one of them is called systematic. I think this came up last time. Systematic, automatic. So I'm pretty sure it came up last time, because we were talking about different ways to pick a sample of gross month students.
Isn't that the one where you like would put someone in a list of every like nth student?
Yeah, so you randomly pick one student and then you pick every whatever after. So let me ask you this. So systematic is basically every nth, every third, every eighth. So if I go out and take the air temperature every 10 minutes, systematic. If I go collect grass every 10 feet for a sample of grass, systematic. If I talk to every 7th student I see, systematic, right? Yes?
Actually, wouldn't talking to every 7th student be
Convenience. Totally. But if my population was just people that are out around me. So you don't know unless you know what the population is. But you're good point. Good point. Okay. More than likely it would be convenience. So systematic can be boiled down to every n. Let me think. I was going to say something else and I forgot. Shoot. Oh, that's it. So if I picked a person at random in the first row, you. Okay, good Lord. And then I picked every 4th person after that. And those people are in my sample. Would that be random? What does it take to be random? Every element in the population has equal chance. If your answer is no, tell me who did not have a chance. Before I started picking, who did not have a chance?
Everyone behind the front row.
What do you mean? Yeah, if I pick somebody in the front row and then I pick every 4th student going like this after that, you with me? All the way to the end. Yes?
The person up there, the person, like the 3 person that's next to the person that's chosen, wouldn't be okay.
But I'm going to pick the first person at random. Couldn't it be this person? Right? Sorry, I forgot your name. Abdi. And then I pick every 3rd, or it could be you, and then I pick every 3rd, right? So before I have picked anybody, is there anyone in this room that would not be able to get in the sample? Good point. But my population is students in this class. 11. Which you could argue that every time I teach, I learn something, so, we don't have to get all philosophical.
The last person?
No, the last person has a chance. I really want this to make sense.
But if you name it like a first, so let's say you pick him, it would be her.
No. See, if I pick Abdi, then I've already picked somebody. I picked the first person randomly. Could I have picked her?
Yes.
Totally, she has a chance. Could I have picked Abdi? Could I have picked Samaj? Could I have picked other people? I don't know their names. Right? Then I pick every 3rd person after that. Well, then you could say, well, the next person didn't have a chance, but I could have picked Abdi. I could have picked Samaj. Everybody would have a chance. That is random. If you apply systematic correctly, it is a random method, but we just call it systematic because there's a system to it. Okay, like it. Now, the next 2 I've got to put up here all at once for them to make sense. There's one called stratified. I think that came up also. And there's one called cluster. So both of these, so for example, if my population is the students in this class right now, are you all broken up into groups? Aren't you? Isn't this a group? Isn't this a group? Isn't that a group? Isn't everybody broken up into groups? So the first step for both of those is break the population up into groups. So for example, if my population is San Diego, Couldn't I break them up into zip codes? And then it can, so, if I break the population up into groups. So let's do this. So, I don't want to put as many rows because there's a lot of freaking rows in here. Let's say there's 3 classrooms on campus that have students right now. You with me? There they are. We've broken our population of Grossmont students who are on campus right now into 3 groups. Stratified would say take some students from each group. And those students are in my sample. Some from all of them. Yes?
And then would a cluster be all of the members of each group that you pick randomly?
From some, yeah, all from some. Wait a minute. Shoot, I forgot what I was going to say. Cluster would say randomly pick 2 or pick some number of groups and then take everybody from those groups to be in your sample. So for us, if I randomly picked 1 person from each row, that is stratified because I took some from every group. Are you with me? Would that be random? Is there anyone that would not have a chance? Student in this room. Anyone that would not have a chance to get into the sample?
No.
If you say yes, tell me who it is. Who is it? All right. Everybody would have a chance, right? If I take it randomly from each row, everybody's got a chance. What if I randomly picked 6 rows? 1, 2, 3, 4, 5, 6, right? And I took all those people. Is that random?
Yeah.
Still random, because I randomly picked it. Do you have a chance? Yeah, I could have picked your row. Do you guys get the idea? If I said I randomly pick rows from this side of the room, is that random?
No.
Because you guys didn't have a chance then. You guys see the difference. So real quick, a little word. Believe it or not, I taught this course once in 3 weeks in intersession over January. January used to be 3 weeks long. And I taught this class 3 weeks. Anyway, sorry, flashbacks. There was a student, when I started teaching cluster, he got upset. This is somebody who was in the military. And this is a while back. So this is right after, do you guys know that there was a whole war in Iraq? Okay. And I still remember, some of you guys might not even have been alive when 9/11 happened. Is that true? Anybody that wasn't born yet? Okay, I feel very old. Okay. I still remember where I was. I was on campus, and we had TVs in the rooms, and we're all standing out there watching the TV and watching the planes and all that kind of stuff, and it was it's burned in my brain. Anyway, a while after Baghdad fell and so forth, they sent out people to survey neighborhoods in Baghdad to see what the situation was like. The problem was, the group of people who did that, they said, yeah, but don't pick these because they're way too dangerous. So then they randomly chose some, but they didn't let these have a chance. So did they apply cluster correctly? No. So they randomly chose clusters, but they made sure not to even give these a chance, and then they kind of saw, and then they wrote a report. And the report was shit, yes? Because they left out, that's unbelievably biased. That's like stupid obvious bias, yes? So then I explained that to him, and he understood that it wasn't cluster's fault, it's a freaking people's fault. Didn't apply it correctly. Are you guys with me? I wouldn't blame him, because supposedly his report said, that's oh, good, what's your problem? And there are whole areas they didn't even go to. Okay. I'll stop. So, so both of these are, if they're applied correctly, and this one also, all of them could be random. The last one is called convenience, and this came up a second ago, and I appreciate being called out because that's true. Most likely it would be convenience. If I wanted to say something about Grossmont College, and I picked you guys who already talked about this, why are you a bad sample? If I want to say something about all of Grossmont College, and you guys are my sample, you're Grossmont students, correct? But why are you a bad sample? It's most likely biased. You're all here for a reason at this time, in this class, taking me, all this stuff. There's a lot of things that tie you together, which would probably bias. Even if it didn't, I don't know. I have to assume it would. I haven't even tried. I haven't even put any effort in to represent. So wasn't it very convenient for me? It's just, and you guys are here, and you'll do whatever the hell I say, so fill out this survey. And you're all like, that's exactly what you had us do. Shit, sorry. Yes?
Well, wouldn't that be different because your population was the entirety of the class, so it wouldn't be.
No, my population's all of Grossmont.
Well, I know, but you were talking about the survey you had at state, so that would be the entire population.
I know, but the joke I was making was the fact that you're a captive audience, and I made you take a survey. Yeah, okay. I'm not going to apply it to all the Grossmont, so good point. You guys all with me so far? Okay. Okay. Last thing. One last set of definitions, and then I'll finally shut up and let you guys work on this worksheet.
What was the formal definition of convenience then?
And
So,
cluster.
anytime you don't even try to make your sample representative, you just do whatever's easy. So if I stood out in front of the door and I just took every fourth person I saw to represent Grossmont College, there's a lot of trouble with that. Does everyone walking on campus, are they a Grossmont student? No, right? So I'm not even trying to make sure I'm representing the population. That's convenience. Yes?
So what would be the word definition for cluster?
So, I'm sorry, yeah, cluster would be all from some weird alternate dimension Three Musketeers thing, right? Some from all and all from some, yeah, sorry.
So you're saying that all of them are random except for convenience?
Exactly, all of them could be random except for convenience. I mean, even convenience could be when I take a sample, I have no idea if it really is representative. I just do what I can to give it the best chance to be representative. Which is why if one group of scientists study something and see some effect, do we trust it yet? In science, if somebody sees something, what do we need to see somebody else do?
Peer review.
Replicate that. Peer review, yes, but replication. I want some other group to replicate the results. You guys understand what I'm saying? Why? Because this could have just been a random fluke. I want somebody else to do it too before I start to agree with it. Okay, all right, okay. Let's see. Which way was it? Oh, yeah, this way. I used to have a eraser. Did I have an eraser? It's my hand again. That's right, this is the room that has no eraser. Do I have more boards? Yes, I do. That's my answer. Oh, shit. Okay. Last couple things. I don't think we've talked about these discrete versus continuous.
Is this still sampling methods?
No. This is something I should have said before that, but.
It ties to quantitative.
Say again?
Does it tie into the quantitative thing?
Yeah, it's kind of like the whole idea, yeah, quantitative, qualitative. So these two would be quantitative. So this is kind of like a breakdown of quantitative data. When I say continuous, what does that bring to mind? Does that word bring anything to mind? Continuous. Ongoing, right? What else? Okay, could be infinite, doesn't have to be. Yes?
Never breaks.
Never breaks, I love it. So, is this a continuous line I'm drawing? Not a line, but you know what I mean, curve. Is this continuous? Is it still continuous? Oh, shit, all right, so, okay. Statistically, continuous data is anything that can take on any value in a range. Could you have 2.7 kids?
No.
Dear God, no. If you do, I don't want to come to your house. Here's one kid, here's the second kid, where's that policeman? Phasing in and out of reality, I don't know. 70% of the time he's here. So, sorry. Number of kids is an example of discrete data. Because can the number of kids take on any value in a range? From 0 to whatever? No, it can only be 0, 1. How many numbers did I skip there from 0 to 1?
Infinite.
Infinite number. 0.1, 0.2, 0.3. What about 0.15793? What about 0.28947? Right? But you can't have 0.28947 kids. So discrete data means it can only take on certain values. It doesn't have to be whole numbers. Does anyone understand that there are cars and trucks that have half doors? So if I said how many doors do you have in your car, the answer could be 4.5. Could the answer be 3.897 doors? If it was, you probably shouldn't go in that car. I don't know what that means. You guys with me? So examples of things that would be discrete level are where the answers must be certain values. So number of doors on a car, even though it could be 3.5, so forth, it can't be 3.87. It can't be anything in a continuum. It'll skip like that did. It skipped, right? Continuous data is almost any measurement. So if I ask you, how far away do you live? Can somebody tell me roughly how far away they live from the college? Roughly. 9 miles. Do you live exactly 9 miles away? Oh, hell no. But you would never say 9.017937 miles. If you did, I probably wouldn't talk to you much anymore. Like, what is this guy? I live square root of 17 miles away. Are you guys kind of with me? So, the idea of discrete versus continuous is what could the value be? So if I say my backpack weighs 8 pounds, just because it's an 8 doesn't make it discrete. It's still continuous because it could be 8.079, it could be 7.938947666 forever. You guys kind of with me? A little bit? Okay. Didn't write much up there. I didn't write anything, but hopefully. So discrete can only take on certain values. Continuous can take on any value in the interval. So for example, if I said the weight of a fish, it could be anywhere from 0 pounds up to whatever the heaviest freaking fish was, right? You can take on any value in there. If I said number of fish, 0, 1, 0. Yeah, that's discrete versus continuous. Okay. Finally, you gotta shut up. So you guys, what I want you to do is much like we did the other day. This room is so good for so many things. Maybe your little groups, somebody could just turn around and work with you guys with me. So see how these 2 rows can go together and the next 2 can go together. Just do it just like we did yesterday. This is a little chapter 1 practice. Okay. Definition practice.
It's like USA deals without like a deal either.
Yeah, it's like what it should be.
You gotta stay there.
Bro, didn't you tell us that there was no word problem?
All right, guys, let me see. A little mood lighting. We got no candles, sorry. All right. So who thinks they have? I think I heard almost everybody get this one right. What type of sampling is this?
Stratified.
Stratified. Now it happens to be random, sure, but it's got a method to it. So I wouldn't just random. The only time you say random is if it's in a hat. I didn't have any method. This was a method. Did I break the population into groups?
Yep.
We totally did. Heavy wine drinkers, light wine drinkers, and people don't drink. And we took some from each group, correct? I'll bet you anything that there are more than 91 heavy wine drinkers in Ecuador. Right? You with me? Yes?
And what about, can it also, is that for convenience, because at the same time you are categorizing them by alcohol, no alcohol?
Sure.
There is-
But no, it's not a convenience because this wouldn't have been convenient for us to do. I didn't just pick somebody who was near me. This is truly trying to make it random. I want everybody to have an equal chance, and everybody had an equal chance, right? You could argue how to define heavy, how to define light, but basically everybody's covered by those 3 categories. So I've broken everybody up into 3 categories, and then I picked some from each. That is stratified. Yeah.
If they're trying to keep it like equal and random, why do they have like
I like it.
more heavy drinkers?
I like it. There's no requirement for the numbers of each to be the same. There is a type of sampling called proportional sampling, which is where you would not just keep the numbers the same, but they'd be the same percentage. So say you're in a high school and there's 1,000 seniors, but there's only 200 freshmen, right? And you want to pick some people from each group. Wouldn't you pick less freshmen and more seniors to be representative? That would be proportional sampling. This is definitely stratified, because stratified doesn't require the same number, the same rate. It's just some from each. Is everybody with me? So trust me, there's more to the story than just these, but these are the really basic ones. Yeah.
So cluster
Cluster would be if I broke people up into heavy, light, and don't, and I just picked 2 of them at random and took everybody.
But they would be equal? Oh, actually, they wouldn't, because, you know,
But do you see how that would not be good? Why did they have to do it this way? If I'm trying to study if there's a relationship between drinking wine and stomach cancer, don't I need representation from all those groups?
Yeah.
So I have to do stratified. If I just did a random sampling, is it possible that I get nobody that doesn't drink wine? Is that possible? Yes. In which case my study would be shit. I wouldn't have that comparison group, would I? So I have to do stratified to make sure I get people from each group. Yes.
If one category was, like, say there are more heavy drinkers than, say, people who don't drink, does that mean that I have to change the amount of people that I select?
If you're doing proportional sampling, then if there's a bigger amount in a group, you are going to take a bigger sample. But this one is not even an option to say proportional sampling. Stratified doesn't get that specific. It's just if you take some from each, that's stratified. Proportional sampling makes more sense because you want equal representation, right? Okay, I like it. But again, if I want to make this into a government class, do you guys understand the difference between the Senate and the House of Representatives? Every damn state gets how many senators? No matter what the shit. But then you get more or less representatives based on your population, right? Let's not even talk about the Electoral College. Okay. Because that's some shit. Sorry. If you live in Wyoming, your vote means a lot more. Your vote means a lot more than in California. Wyoming person's vote means a lot more than any of us. I'll stop, I'm sorry. All right. I have nothing against the people of Wyoming. Just the way that things have been set. So this is definitely stratified. Why? Because broken into groups. And then we took some from all groups. Is that okay? Maybe? What's the population here? I like it. All Ecuadorians. Anybody from Ecuador? I'm pretty sure it's Ecuadorian. That's how you say it.
Did you say that all Ecuadorians of drinking age?
Not necessarily, because tell me this: what might cause stomach cancer? Could a baby be born with stomach cancer?
Yeah.
Yes. So they would want everybody. So what they're trying to tease out is there a relationship? So could some of the people that don't drink wine have stomach cancer? Because wine is not the only thing that could cause stomach cancer. But if you do the study, you could still see, is there some effect wine has? Does it increase the chances? Right? So you could argue I would want babies to be represented in this, right? Anybody. And by the way, I don't know what the drinking age is in Ecuador. So, is it 18? Okay. Do you know every country? No? Okay, you just have to drive it. No, I'm sorry. It's not there. When I go traveling, I just wanted, okay. Sample. Here's the funny thing about the sample. If you know the population, you automatically know the sample. You replace the word all with the total number in your sample, and you're done. Because where's the sample come from? The population. So that if the population is all Ecuadorians, the sample is some number of Ecuadorians. What's that number? Anybody add them all up? 261. Now you could also just copy whatever the hell it was, 91 heavy wine drinkers, blah. That would be correct. It would just be a lot more writing than you have to do.
What would I say?
261 Ecuadorians. Okay. Part C, this should have been pretty straightforward because I say the word. Is it a parameter or a statistic? Why? It describes a sample, right? Statistic describes sample. What is a parameter do?
Describe the population.
Describes a population, yeah.
So can you never use parameter if you're using a sample?
No, if they would have said, based on our studies, we believe that 3% of the population has stomach cancer, that would have been a parameter. It would have also been what's called inferential statistics. They would have inferred something about a population. But if you ever describe a population within numerically, That's a parameter. Does it make sense?
Yeah.
So there, they describe the sample numerically, statistic. Kicking the ass in, I like that, okay. All right, then we get into the fun stuff. So on these kind of questions, don't look at the numbers. Say, what would the question be and what would the data look like? So on 2A, there's actually two answers I would take. There's a very straightforward answer. Why do they give numbers out at delis?
Keep track of the orders.
Keep track of the order, right? So you're gonna come and you know, has anyone ever, back in the day, Panera would give random numbers. Like I got 157 and the next person got 28 and I'm like, how long do I have? So, but they would, behind the scenes, they would keep track. So, but in a real deli, ever been in a deli where you just pull a number and then the next person comes pull a number? So obviously the main purpose of those is to keep the order of the people, so they take people as they come. So obviously that would be ordinal. Did anyone have any options besides ordinal? Yes.
Interval.
Why would you say interval?
Because you can count like two people, you can, if one person has number 2 and one person has number 15, you can say that the other person like 13, 15,
Kick ass. So if I had number 7 and somebody else has number 10, I'm 3 places ahead of them, right? The difference means something. So I would accept either answer. The most important part of this question is the why. If you just put an answer and don't say why, you're gonna lose more than half the points. Because the most important part of this question is explaining why. You guys with me? So there will be a few that, depending on the way you look at it and you explain it, I would accept more than one answer. Amazing. Now, in the example with Panera, right, that would go to hell, right? 157 minus 28, I was in front of the 28, so that doesn't even, right? So it does depend on if they're really giving out numbers in order. Okay. I would also argue Panera is not really a deli. So I would accept interval, and you would explain that the subtraction would show you how far you are away from each other. Part B, people look at the percentages, and they give me the wrong answer. What would the question be that I asked people? What's the question I would ask them? Or what would I look for?
What color is your hair?
What color's your hair? And that would be, of course, nominal data. But I always get somebody say, well, if there was 15%, that's half the 30%, so that's ratio. But were the percentages the actual data? No, I was taking, what's your hair color? What's your hair color? I was writing that down. So that would be nominal because it's just hair colors. All right. By the way, before I forget, I am eternally going to let us out a little early because technically, for any class that meets for over 2 hours, I'm supposed to give a break. So what's funny is this class used to be 1 hour and 50 minutes, and now it's 2 hours and 5 minutes. So if I gave you a break, it actually becomes the same amount of time as it did before. So what I'm going to do is, instead of giving you a break in the middle, I'm going to give you a break at the very end.
Nice.
If anyone has a problem with that, just come see me, and I'll laugh at you. No, I'm joking. We'll discuss it, right? If you ever need to use the restroom or anything, don't ask me. Just go. Just go use the restroom. So, number 3, same idea. They say the fish weighed 2 kilograms. What could it have been?
Continuous.
Yeah, it's continuous because it could have been, could be what? 1.987 blah, blah, blah kilograms, right? And they just rounded it because we're normal freaking humans, right? We're humans. You guys kind of with me? So don't look at 2 and say, oh, that's a whole number, so it's discrete. Did it have to be 2? No. Look at this one. 2.3 is a decimal. That's continuous. No. What is it they were looking for? The number of TVs. And then they took an average. So what number of TVs has to be? A whole number, so that would be discrete. Yeah. I like it. I like it a lot. Okay. Discrete must be whole numbers. Certain values. So discrete doesn't have to be whole numbers, but if it has to be whole numbers, it is discrete. Because discrete means it has to be certain values. That feels like enough, but too bad we're not done. Sorry. That's most of chapter 1. there is something in chapter 1, somebody asked me about that chart that you have to kind of count. We're going to do that, but the funny thing is, to me, that is a part of section 2.2. So what I'm going to do is I'm going to do section 2.1, and then we're going to do section 1.3 and 2.2, and then we're going to get the hell out of here. Right? We're actually going to go on a field trip, but then we'll get the hell out of here. All right. Any questions on this handout? Right. Okay. Yes? That's yours. Fucking A. Oh yeah. Now I'm in trouble. All right. I'm not quite in trouble yet. Oh no, just never learned. All right. Getting now. I got 2 layers left. So, chapter 2. Remember I just brought up the idea of inferential statistics, where we take a sample. So anytime you hear in the news, we took a poll and 40% of Americans are going to vote for this guy and 42% are going to vote for this guy, right? It's almost always freaking guys, but oh well. You guys all with me? Is that true? Did anybody talk to you? Anybody in here going to vote? You don't have to raise your hand. I'm sure some of you guys are going to vote. Did they talk to you? Did they say, hey, well, who are you going to vote for? No, they didn't talk to frickin' me. So that's called inferential statistics. They took a sample and then they tried to say it's true about everybody. Right? Now the way they cover themselves, and later this semester, has anybody ever noticed, anytime you saw like they have something, I gotta be really careful with what I write, 40% gonna vote for Jim Bob, 42% are gonna vote for sorry. I'm really loopy. Donnie the man. Then at the very bottom of the screen or whatever it is you're looking at, they'll have plus or minus 4%. Right? Have you guys ever noticed that? Yeah. Good old Jim Bob and Donnie boy. I love it. Or Dark Brandon. That'll work. All right. So later this semester, we're actually going to learn the math that goes into this number. This isn't just them in the back room going, "Oh, sure, are we about this?" Oh, like give or take 4%. No. What do you think would make that number go down? What would happen if we? I'm sorry. Go ahead. A larger sample should decrease the uncertainty. Does that make sense? So whatever the math is that goes into this number should include how large your sample is. Does that make sense? Because the bigger your sample, the smaller this number should be.
So this is kind of unrelated. So when they say there's a 5% chance of rain, that's gonna be like 5% of the population. So you guys have to take like a 5% chance of any rain at all.
There's so many ways. Real quick, if they say like a 5% chance of rain, the most immediate thing that most likely means is that 5% of the area will have clouds that could create rain over them. That's one way it could be interpreted. Some weather events are like have you guys, all right, so I can finally say this. I used to live in Florida and Georgia and Virginia, and my entire early life was dominated by hurricanes. In the summertime, we just had tape on the windows. That was just the way it was, right? Did anybody else live in those areas? Anybody else experience hurricanes? If you've lived in San Diego your whole life, this Hillary thing was completely new. Yes? Did anybody notice the cone of uncertainty? Anybody look at the hurricane's path at all? So they had a cone of anything I write, I can't delete. So here is my incredibly bad drawing of the U.S. Okay. Here's and of course Mexico does exist. So okay. So here's the hurricane, and then they have this cone of uncertainty. right? And then if you wanted to, you could turn on the average path, right? How did I get here? Sorry. So that would mean in the history of every recorded hurricane event, when the conditions were such, it would mostly go down that line, but it would have some variability off that line. There were sometimes it would go this way, sometimes it would go that way. Does that make any sense? Whoever asked this question, I forgot already. I'm sorry. Did you ask this question? So yeah, so sometimes it's just there's 5% of us have a cloud that could present rain over us. So there's a 5% chance of rain. Or it could be in history, we've noticed this percent of the time this happens when the conditions are this way, right? Okay, cool little question. I like it. I gotta back up to where I was. Okay, so chapter 2 is not about inferential statistics, it's just descriptive. When I take a sample and I want to present somebody what I saw in my sample. So chapter 2 is all about descriptive stats. The most basic descriptive statistics you could create. So this is going to be graphs of some kind, or calculations, analyses. Calculating averages is a type of descriptive statistics. So a graph is a really descriptive statistic. So let me, I'm going to make up some data. Let me see. What you got, Jeff? 14, 16, 19, 19. You don't have to say it as you write it, buddy. There you go. Okay, so maybe this is ages of people at a bus stop, right? The most basic descriptive statistical graph I could create is called a stem and leaf plot. Stems. So the stems in this case, do you notice how there's a bunch of numbers in the teens, right? There's a bunch of numbers in the 20s, so forth. So isn't there a repeated digit? The 1 is repeated, the 2 is repeated. The stems are the first piece of the numbers. So my stems would be 1, 2, 3. Don't skip 4. So what's going to happen is, sorry, I kind of set you up for that. 4 is just going to be empty, which is good information for us. So those are the stems. Off of those stems, what leaves? So for 1, I have a 4, I have a 6, and I have a 9, and I have a 9. You guys see how that works? Stems, leaves off the stems. What comes after 2? 0, 1, 7, 3, 3, 5, 4, nothing. 5, 1. Right? And if you tilt your head this way, doesn't it become like a little bit of a picture showing you how the data is distributed? Most of the data is in the teens, right? There's nobody in the 40s. You guys all with me? Very quick to create, and it does become a visual if you tilt your head over. There's one problem though, this isn't done yet. I am not going to give somebody the data, because this is a very small set of data, correct? But I could have like 5,000 data points, and then I could create one of these. I am just going to give somebody this picture. I'm not going to give them the data. They have to know how the hell to read this damn thing. So I have to tell them 1 line 4 means 14. So that is the key. The key master. No, that's the key. That just explains to somebody how to read it. And when you have a map, what do you need? You have a map. What do you need in the corner? A key telling you how to tell distances on the map, correct? And when you zoom in, the little distance thing changes to tell you how the hell to read the map. That's what this functionally is. Now, real quick, everybody got this copied? Don't write what I'm about to write, just watch. Your notes will get all freaky, just watch. If the data would have been this, 1.4, 1.6, 2.0, 2.7, if that was the data, this would look exactly the same. That would say what? 1/4 equals 1.4. You guys see the need for the key now? Because if I just see this, it could mean 14. It could be 1.4. It could be 1400, 1600. I don't know until you give me the freaking key. Is that cool? So when I ask you for a extended leaf plot, it's not complete unless you write the key. If you don't write the key, you lose points. Okay, I'll lock it. Good. That's silly nice. Let that be nice. Yes? Isn't that nice? Enjoy it while it's this nice. Okay. I'm looking at my US, it looks like a cow, but I won't. Absolute last thing for today. Actually relates to two different sections. And it has to be the last thing because this is my last layer of board. So this goes back to 1-3, I believe, wherever that chart was. I think it was 1-2 or 1-2, okay. And also 2-2. Have you guys ever seen, something like this? Yeah, I'm gonna go back to BMW, I'm gonna go back to Hyundai, whatever the shit, and then Ford and whatever. 5, 10, and then you have this. You guys have seen stuff like that, yes? Bar graph, I love it. What kind of data is on the scale, the X scale? What kind of data is that? Nominal, qualitative, kick ass. Both of those are beautiful, yeah? Does this being empty mean anything? Doesn't mean shit. There ain't nothing there, right? What about this kind of graph? What kind of data now is there on the x-axis? Quantitative, numerical data, right? I don't know if it's ratio or interval, but do it. Does this being blank mean something? Yes, it means nobody was from 20 to 30. If this is ages, nobody was from 20 to 30 years old, yes? So gaps here mean something. So if you have a gap, you better be sure you want it. Here, I don't give a shit. Gaps don't mean anything. It's just separating the bars. Who cares? Are you guys sorted with me? This you said is a bar graph, which is correct. Anybody know what this one's called?
Histogram?
Histogram. That's right. Low whistle is correct. That's a histogram. It's only one, so I can just do that. All right. God, I'm tired. Sorry. I'm going to be loopy a lot, and I apologize ahead of time. Now, so we're going to create that histogram. Let me ask you this. How many classes are up here? Oh, that's a neat question. How many, just your gut reaction, how many classes?
2.
Nope. How many classes are empty?
1.
Good. So how many total classes are there?
3.
Good. You see this class, this class, this class. How wide is each class? 10, right? Everybody with me? Amazing. Now it's not going to work as well in here. My other class was really cool because it had partitions. This one doesn't really. So, oh well. Let's say I want to cover. This with wood paneling, right? Let's say I want to cover it with wood paneling. Are you guys with me? I don't have a way to measure this, but let's pretend like this is maybe 5 feet. Yeah? I don't know. Let me lay down. It's a little more than 5. Who cares? Pretend like it's 5, right? If I want to use, go with me. So what I'm about to do is I'm going to give you a physical feel for the math we do. I want it to make physical sense. So just hang on. 5 feet across. Let's say I want to use, it's too easy. If I want to use 4 panels, how wide would each panel have to be to cover this board?
1.25
How did you get that?
division.
The distance you got to go, right? Divided by the number of panels you want to use, correct? I want to go 5 feet and I want to use 4 panels. 5 feet per 4 panels, 1.25 feet. So each panel would be 1.25 feet wide. Are you guys kind of with me?
Mm-hmm.
Okay, good. That's not my data. Now, I'm going to relate that math to what we're about to do. This weird shadow. I'm going to make up some more data. Oh my God, okay. All right. Oh man. So whenever I'm doing stuff in the class, I'm just going to make data up. When I give you a quiz or a test, I actually like to give you real data. So I get it from the census. I get it from there's a thing called Gallup that does a lot of polling, or whatever. So obviously, I didn't just go ask people how old they are or whatever. Just made those numbers up. I should have been a little more clear about this. How would I know this is 5 feet long? What if this was at the 10-foot mark and that was at the 15-foot mark? That would mean it's 5 foot long, correct? How long is my data? How much is my data range? Make it a single number.
28,
26.
Oh,
So that's just like the 5 feet. I want to see how far do I have to go to cover my data. I got to go 26, don't I? So to get the class width, to get how wide each frickin' rectangle has to be, I see how far is the total distance I have to go, divided by the number of classes I want to use, just like divided by the number of panels I wanted to use. Exactly the same idea. In general, we use anywhere from 5 to 10 classes. So we're going to have 5 to 10 rectangles. The bigger your sample is, the more you use. I'm never going to give us 800 data points. Do you understand? I'm never going to do that to any of us, right? So we're almost always going to use 5 or 6 classes because their samples are going to be kind of small. All right. So what did you guys say? It was 30 minus 4. That's how far I've got to go, right? Divided by the number of rectangles I want to use. So let's use 5. What is 26 divided by 5? Here's a quick way to divide by 5. Double the top. So double things. Do you see how it's divided by 10 now? Divided by 10 is easy because you just move the decimal back one place. And of course, some of you guys are like, I got this thing, it's called a calculator. Yeah, okay, great. You can put it in the calculator also, right? All right. If you ever get a decimal number, just round that sucker up. We're going to make it 6. So just like this had a width of 10, ours is going to have a width of 6. Okay. How are we doing with time? We're doing pretty good. Okay. So now I want to construct the classes. What does this mean? How many numbers were from 10 to 20 here? 9. So when I construct a class, I then want to figure out how many data points are in that class, right? That's going to tell me how tall that bar is. Okay. So the first data point is 4, correct? If the classes are 6 wide, and the first class starts at 4, where should the second class start? I know, there's a lot going on here. If the first class starts at 4 and they're 6 apart, the next class should start at 10, correct? Someday I'm going to ask. I can't put 10 here because then I wouldn't know where to put 10 if 10 was one of the data points. So I have to put 9. Does everybody see that? So you don't see the width this way, you see the width this way. I'm going to show you the way that I was taught. This is the textbook method. This is the way you're going to see in the textbook. I'm going to show you the way I was taught. You can pick whichever way you like. So I'll show you in a minute. So now I can just keep adding 6 because the width is 6. So like if I add 6, I add 6, I add 6. They get the idea, Jeff. You can stop saying add 6. Until I get to 5 classes. Did I capture the last data point? Does the last data point have a place to go? Yeah, it's in here, right? Okay, all right. So now I want to just count how many data points are in each class. And that's what we call the frequency. I fractionally call it the freak, but it's the frequency. How frequently does a data point show up between 4 and 9? 3 times. You guys see that? There's 3 data points from 4 to 9, 10 to 15, 4, 16 to 21, 2. Does everybody see where those numbers are coming from, just to be sure? 4 to 9. How many data points fall between 4 and 9? That's it. Yeah, yeah. I always have somebody put 5, 5, 5, 5 because I think they're just seeing 9 minus 4 is 5. It's the number of data points that fall in there, right? What about 22 to 27? Yeah, 1, 2, 3, 4, 5. And then 28 to 33, that one lone dude out there. Now, being a math geek, I love that it's 1, 2, 3, 4, 5. But anyway, that doesn't matter. There's nothing about that. Just to tell you, we're now going to make percentages because percentages make more sense to humans, right? I've heard that humans like percentages. So, how do I make a percentage out of these? How many total numbers are there? How many? How many total data points are there? Thank God these added to be 15. So it's a nice little check. Make sure you actually add up to be the right number of data points. The worst damn thing in the world about statistics is all of the data that you have to keep track of. If you miss one, that sucks. So being like, oh God, I missed one. Which one did I miss, right? So just be careful. I do give partial credit. So if you do everything right except you missed one data point, you're only going to lose data points once. Does that make sense? Okay. When I make a percentage out of these, so for example, how many data points were in this first class? Out of how many total? So then I can make a percentage 3 divided by 15, 20%. We call this, we don't call it percent, we call it the relative, I'll write it out, relative frequency. I actually call it the real freak, but relative frequency just means percentage. By the way, just to let you know, next class I have a worksheet where you can get practice with this. This is not the last time I'm going to talk about this. All right. Keep going. What's 4 divided by 15? Somebody help me out. Do it again, sir.
2.6666, so would you round that up to?
No, is it 0.266? So it's 26 point?
No, it'd be 2%.
No.
2.6 something percent.
It can't be 2%. It should be close. It should be more than 20. Yeah, 26.7 if you round it. Is that right? Okay. 2 divided by 15. That'll be like 13.3.
Yeah.
Yes? Okay. Just half of this dude, right? 5/15, that's 1/3, which is 33.3%. 1 divided by 15 would be 6.7%. Check me on that, you never know. Okay. What should all these add up to be? Will they always add up to be 100%? No, because what did we just do? Did we round? Couldn't we happen to round less or more? So it could be like 99.8% or 100.7%, whatever. So it doesn't have to add up to be 100 because of the rounding that we did. Okay. We're almost there, guys. When I go to construct this picture. All right. Any questions on what we've done so far? We're going to do another example of this, so don't feel like you got to understand everything perfectly right now. I'm about to do something really weird. I'm fine. I didn't forget any meds. There's a limit to me, correct? This is where Jeff ends. Is Jeff here? No, Jeff is here. I love doing this because everybody's looking like, oh my God, should I leave? Should I need help? There's a limit to me, correct? There's also a boundary to me that if you step closer than that, I better know you really well. Is everybody with me? If you come like in my grill, if you come right here, I better know you. I better want you there. Is everybody with me? What the shit does this have to do with this? I'll tell you. These are called the class limits. If I try to go graph right now, isn't there going to be a gap between 9 and 10? Doesn't that mean it's an empty space? Doesn't that communicate there's nothing in there? Is that really what I want to say? No. I don't want there to be any gaps unless there's an empty class. Are there any empty classes? Can't be any gaps. So, go. If I go down a half and up a half, down a half and up a half, you guys see how these overlap at 9.5 now? No gaps. These are the limits. These are the boundaries. So if I go boundaries, the boundaries line up. There's no gaps. Personally, I don't like this. So if you're like, I don't like it either, I'm going to show you an alternate method in a minute. So the way this would look is 3.5, 9.5, and then I'm just going to keep adding 6 because the width is 6, correct? I can just keep adding 6. Add 6, add 6. Right? Yes?
So why couldn't you just do 4 to 10 in the first place?
If there was a 10, so for example, of course there's no example, here, there's a 22, isn't there? So if this was 16 to 22, where would 22 go? Which one of those would 22 go in? Yeah, okay. Stick with me. If I make a relative frequency histogram, so I want this to be based on the relative frequencies, what's the tallest bar that I need? What's the highest I gotta go? Not frequency, relative frequency. What's the highest I gotta go? 33%, right? So maybe I'll go 5, 10, 15, 20, 25, 30, 35, okay. So you gotta pick a scale. Relative freak. And this would be, I would just say ages. I don't know if I said it, what it was. So how tall will that first bar be for the first class? 20, right? The first class goes up to 20%, correct? You guys see that? So this is the easy part, 20%, and then the next class is 27% almost, so a little bit above 25, and the next class is 13, so it goes to 13, and the next class is 33, way the shit up here, wee-haw, and the last class is 6. Okay. Thankfully, it's not flicking us off. It's got its ring finger up. Would you say that looks bell-shaped at all? Nope. If it's bell-shaped, where should the tallest bar be? In the middle. I love it. Okay. Now, real quick. If you don't like this method, this is the textbook method. Here's what it would look like, my method. Yeah, screw you guys. And again, you could just pick one of these methods. By the way, we're almost done for today. I can feel you guys like, oh my God, we're almost done. Maybe it's just me. This first class would look like this. Next class would look like this. Do you see why people, and right now I can feel people going, I don't want to do that shit. You told me there's going to be very little algebra. I see X's. So where would 10 go? Which class would 10 go in? The second one, because that's where it's allowed to equal 10. This is not allowed to equal 10, right? But don't I see the width this way and that way? And then this would be 4, 10, 16, the way you want it to be, correct? So you got to pick this method or that method. This method is better because it makes this, but it also has a little more complicated look to it, right? But you get to pick. Okay. I see some of you are like, I'm picking neither one. Let's see how that goes. That's not going to end well. I think that's enough stuff. So what I really want to do is I don't want anybody to leave. I want us all to go on a little field trip. I'm going to make it as quick as I can. Little field trip, right? Go with me. Can everybody do me a favor? Pack up, go in this direction a little bit, and then stop. Wait for me. I'm going to pack up. Okay.